Hey everyone, and welcome back to the EdgeVerse Techcast. This is your go-to place for everything related to NXP software tools and enablement. And everything we're talking about here is tailored specifically for NXP processors and microcontrollers. I'm your co-host, Kyle Dando, and today, Bridgette, we're finally going to talk about the most talked about topic on our EdgeVerse Techcasts. In the past, we did the most downloaded topic, but this is the one that's been in almost every episode that we've had, and that's the Doom application that's on the Application Code Hub, and it targets the MCX FRDM board.
This has been such a popular demo, so it is great that we're talking about it today. It's finally here.
It is. And to do a good job of giving you, the listeners, the information of what's so great about this, we have Peter Vanderperk joining us. Peter was the engineer at NXP behind porting Doom, but we will let Peter introduce himself a little bit better.
Good idea, Kyle. And hello, everyone. It's Bridgette Stone here with Kyle and Peter for what I think is going to be a great episode. Peter, thanks so much for saying yes and joining the TechCast today. Can you start by letting the listeners know a little bit about yourself?
Well, thank you guys for having me. I work for NXP. I'm Eindhoven-based, and actually I'm working mostly on mobile robotics, where we work on system solutions. So we try to make a full solution for subtopics for robotics, either be it motor control or batteries or even some autonomy systems. And with that, I'm using a lot of NXP technology, and we want to showcase how we can use that.
Well, thanks again for being here. And where I want to start, I know this demo has been so popular, and we'd love to peek behind the curtain and understand, where did you get the inspiration? Where did you cook up the idea? How did you even come up with porting this over in Zephyr?
So for our robotics reference platforms, we use Zephyr a lot, but that's mostly sensing some data and then making those actuators. So I was working on some drivers, and you always see just things coming in and out. Then you're looking at microcontrollers nowadays are crazy powerful. Actually, then I was working on the IMX RT1170, so that's a gigahertz microcontroller, which is crazy fast. I wanted to have like an offsite experiment with Zephyr. Like, hey, what can we do with Zephyr as well? And then it came about there are all these people porting Doom to all different platforms. Well, maybe all these microcontrollers I'm working with are probably fast enough with that. So the idea was, let's try to learn some new subsystems of Zephyr, because Zephyr it's a very powerful RTOS, but it has all these regions or subsystems you're not used to. Then combined with like, hey, okay, display systems, input subsystems is quite new. Let's try to get Doom to work, and maybe you can also play around with that a bit.
All right, so you started to jump a little bit into the details there, but I'm interested. Was the Doom source already in Zephyr's community? Did you have to work to get it in there? And then how did you integrate it into the NXP development environment? What tools did you use?
So Doom got open source in like 1998 already, and then there is this source code that runs on a very old Windows PC or Linux. There are surprisingly a lot of different ports for different platforms. So be it a Game Boy I've seen, or to a refrigerator. I wanted to see if it already was done for Zephyr. To my surprise, it was not. So I just started with a clean slate sample application. Zephyr has a very good documentation how to just make your basic application. I just took the code. There are actually different ports. The particular version I took is called PR Boom. There's a whole family of that. You could take a look at the Wikipedia for Doom, but that was the version I chose to use. The first thing I just wanted to do is to get it to compile. The nice thing about Zephyr is you don't necessarily have to run it on your hardware directly. Zephyr also has this mechanism which is called the native simulator, and that was very useful for me. Because of that, I could already build the application, look at how big it was, because obviously I think Doom was made for like a PC with 16 megabytes, but our microcontrollers are between 4 or 8 megabytes depending on the chip you have. So we also had to optimize to fit it to that size. So just getting to build and getting some data on how big that was a very nice start. Then I pretty much looked around the internet about the crazy board other people did, and just one by one looked at the optimization technique and tried to apply that.
Well, I think we have a lot of engineers that are very grateful for your work. So thanks for doing that. And I know we also included FreeMaster, which is one of our most versatile tools, as part of the demo. What a cool concept to help visualize not only the performance of the device, but the map of the gameplay. Can you talk high level of how we decided to integrate FreeMaster into this demo?
Yeah, I found it a very surprising choice that our colleague working with FreeMaster did that. So I'm aware with FreeMaster, but typically it's very useful for a motor control or something else, which is real time, where you want to have data in real time, but you cannot press a debugger because if you have a debugger and your motor is spinning, it doesn't work. But it was very cool where they're like, okay, but let's just visualize the current data what's there. So the CPU load and some other metrics. And they even went beyond. It was like, okay, let's fetch the game state out of it and visualize that. I think it's a very nice demo on how powerful FreeMaster is, and that even the basic motor control demos, you can even go further. It just really used FreeMaster as a tool to develop further.
So, Peter, are there any other NXP specific features that you also use? I know you said FreeMaster is one, but any other interfaces?
So the target right now, if you go to the application hub, is targeting the MCX N947. Actually, that has this FlexIO interface, which is a parallel data interface. That was very useful to display the data on the screen because it's very high resolution, I think like 400 by 320. If you're rendering those frames, you also want to get them very fast to that screen. That was very useful, and it was also a very nice experience because everything was already enabled in Zephyr, and I could just show the frame. I didn't measure it, but it's like very fast, so that's nice. Next to that, I was thinking I might have to use it, but the M33 core, we have like a special MET accelerator because it's also used for motor control. But surprisingly enough, the CPU core was already fast enough, so I didn't have to use that. But if you want to have more performance, there's lots of wiggle room on that microcontroller.
Peter, to quote my favorite movie, Zephyr, we love Zephyr. Zephyr's our favorite. That's from Elf. But seriously, what did you discover when you worked with Zephyr? You've talked about how you found it very interesting and it was something that you learned quite a bit about. You have a lot of experience in programming. Can you talk about any specific benefits that you saw when porting Doom into Zephyr for NXP specifically? Just things that you might have noticed that Zephyr was a benefit.
I think the biggest benefit for this project is that you could target your PC. They call this the native simulator. Switching to the actual target was literally say, okay, now build this program for that board, and it just ran. I already had screen, didn't have to debug, so that was a bit of a wow moment for me. It's like I was expecting to debug that for who knows how many hours. That's really the powerful thing of it, is just the board support and also a very fast bring up. If you want to hook up a sensor, there's a driver for it. You have to go to the device tree, just work out your board, take your schematics, and you're done. That's like very quick to do. There are lots of these shell applications Zephyr has to test these hardware. There's a whole testing framework. So yeah, you really quickly get this wow effect where things work.
So you added the joystick shield board on the Freedom board. Was that pretty easy to integrate because Zephyr had all the drivers already set up for that specific shield?
Yeah, actually, that's a very good example because the joystick is an analog input. And if you have an analog input, you have to calibrate that, you have to figure out the center point. But there's already an abstraction that did that for you automatically. So you just told it, okay, this is a joystick, this is the ranges, and done. I didn't have any drift, any problem. You just use it out of the box. Actually, same applies for the touchscreen as well. The screen has a touchscreen, and I could just use the simulator first with the mouse cursor to simulate the touchscreen, and then on the real hardware, it was just working.
That's great. So I have to ask, I'm one of the product managers for our Visual Studio Code development environment. Do you use Visual Studio Code? What environment do you do your code development in?
Actually, I use Visual Studio Code a lot. I really like it because switching from either Zephyr to Python or some other language is nice to just have one single environment where you're just used to your hotkeys and your interface and so on.
Yeah, we're getting a lot of feedback from customers that this is their preferred. It's a software development environment, right? It's not the traditional Eclipse is more hardware based. I think software developers really like the flexibility of Visual Studio Code.
Well, it caught up nicely because I tried it out a couple of years ago and I was still using Eclipse, but then I was really missing some features, reading out registers, assembly, and so on. But lately, like past half year, you pretty much have all those features, and you don't lose out from switching to Eclipse to Visual Studio Code.
Yeah, I hope you and the rest of the NXP team and our customers go and load the project in Visual Studio Code. Before we get to our last question, you were at the Zephyr Open Source Summit, correct? You did a presentation similar to what you're talking about today. What did you present there?
Yeah, there was this Zephyr Developer Summit, which was part of the Open Source Summit. And this year it was in Amsterdam, so it was on my home turf. It was kind of more like these war stories of how we did it. I went into technical details of some challenges we had. There's even a recording of that, so maybe you can put a link on that. But yeah, some nice explanation how they did it, how powerful Zephyr is. Also inviting people to try it out because it's very nice and easy to use. And hopefully people can even use other platforms.
Excellent. Yeah, I'll put that in the episode notes so that people can see the longer explanation of how you did it, because I know there's quite a bit of work that you put into it.
Okay, Peter. So after the listeners check out the recording from the Open Source Summit, I think a fun call to action would be how to get started. And I know that the code's available on GitHub, but it's also available on our Application Code Hub. Is that how you recommend for people to get started and discover more of your work?
Yeah, so if you got Visual Studio Code set up and you have our extension, then just go to the Application Code Hub, you press the button, it downloads it, you have your project, and if you have a board, you can immediately try it out.
And I think, Kyle, the expansion boards are all on the Expansion Board Hub, correct?
Correct. Yeah. In the Application Code Hub for Doom, it links all the boards. So if you don't already have that analog joystick or the touchscreen, it'll link to the place where you can get all the proper hardware.
Awesome. We'll add all that to the notes of the episode.
All right. Well, again, Peter, thank you so much for joining. This is a long time coming. It's nice to see a software developer share a story about how they took something as popular as Doom as a personal challenge and was able to integrate it into an NXP Freedom board with a little ingenuity. So thanks for joining today.
Yeah, thank you for having me.
To summarize everything that you shared, Peter, the main thing is that Zephyr is an ecosystem that allows people to take software and put it into a very mature environment. Something that you mentioned is the ability to do the desktop simulation and then change the target from the simulation environment to a target board. You said that it's seamless, it takes advantage of all the proven and the tested drivers, and it made your job a lot easier. That's what we've been hearing from a lot of our customers and from our own Zephyr developers. It was great to see a real-life use case where you took a challenge, you opened it up in the Zephyr community, and you were able to solve that problem. So that's a great testament of the benefit of Zephyr.
Yep, couldn't agree more, Kyle. Again, Peter, thanks for being here today. And for our listeners, if you enjoyed this conversation, don't forget to like, subscribe, and turn on notifications so you never miss an episode. And if you have a topic you'd like us to cover, please drop a note in the comments and let us know anytime.
And until next time, always keep innovating. Maybe take some time to play some Doom. And we'll catch you on the next EdgeVerse Techcast.